Good evening, everyone. Let me take this opportunity to welcome you back and also to welcome the rapporteur for the session, Draman Kaba, from Ivory Coast, Cote d'Ivoire. Thank you, Chair. I think we will proceed. So we are supposed to have a keynote by Zakaria Bengali, but he gave his presentation earlier during this meeting, so we will skip that. So Zachary Bengali is not giving the keynote that is indicated in the program. So we will start with session 5A, and each presenter has 10 minutes. I hope we can go through as many as we can to make up lost time. And let me just also say that not many people have uploaded their presentations. So is Simon Peter Musinguzi here? Simon Peter Musinguzi? Okay, and Sisai Alemu Mamo? Okay, if they're here, they will give their presentations, but for the moment, we will go to the next one, which is being given virtually, and that is from Benita Anderson. So please help us to set up that. Benita, are you online? Can you hear us?
Yes, good afternoon from here.
Benita Anderson?
Yes, please, I'm online. I can hear you.
Okay, I can see Juliana sending Benita a quick email. Okay, Benita, can you share your slides? Unless you want us to present for you. Okay, this is going to take us a little while to set up as part of our catching up process. As we wait for Benita, is Bedaso Kebede here? Bedaso Kebede, who has 2 presentations. And then Margarita Gonzalez. Okay, looks like the animal trips were swallowed by
la trips animal a été avalée.
Okay, is Savidzem Silas here? Okay, Benita, you can hear?
Yes.
Okay, can you share your slides? Or do you want us to share them from this end?
Hello.
Hello?
Can you hear me, please?
Yes, we can hear you. Yeah. Please share her slides, huh? Can you? Okay. Okay. We can't see your slides yet. We can hear you, but we can't see your slides yet.
Good afternoon from here, and good day to you. I don't know what time it is there, but I thank you for giving me the opportunity to present the paper on adapters to support the progressive control of transmitted animal trypanosomiasis in Ghana. My name is Anita Anderson, and I present this paper on behalf of my co-authors, Yaya Adam, Yakubu Sankara, Enoch Soti, Iliana Teti, and Maximo Pion. So, to give you a bit of introduction, as seen in the figure there, Ghana lies within the infested belt of Africa. 60% of the landmass of Ghana is infested with and by extension, trypanosomosis. The main control method adopted in Ghana is by vector control.
Benita,
we have data on...
We can't see your slides yet. Okay, now we can. Okay.
Sorry?
Let's go ahead. We can see your slides now.
Okay. So I will say that the main method of control in Ghana is by vector control. And then we have information on the past activities, geographical distribution of the vector, the disease, and then other information is all available in the country. However, the information is static. They are not harmonized for us to be able to make any analysis and have any meaningful information from it. So we set out to do this work to be able to put everything together to be that would help us really take decisions in the country. It is important to know that in the past, efforts to control AAT and TETA in Ghana have been done, especially in the 1990s. There were large-scale community-based vector control operations involving deployment of iconical traps, insecticide targets, insecticide-treated cattle ground spraying, and also chemotherapy. This was also noted by Mahama in his publication in 2003. Most recently, under the African Union patent, there was also a large-scale control operation that was an integrated approach using all the previous control measures, including sequential aerosol technique that was done in the Upper West region of Ghana. All this information, like I said earlier, is still available, but they are not put together in a way that would allow analysis and decision making. So the broad objectives for this paper was to develop a national data repository on TETA and trypanosomiasis occurrence. The second one was to enhance and update the national TETA map and distribution in Ghana. All of you bear with me that the 4D Katondo maps are outmoded in the sense that pressure on land and land use have changed since then. Our third objective was to develop a comprehensive national TETA and AAT information system, which can be easily and regularly updated. Because what we had before we started this work were on paper, and it was quite difficult sometimes to even take these papers to look out for information. Our other objective was to develop a national atlas that would inform decision making, which would also guide us for mapping the progressive control pathway of Ghana. Materials and methods that was used for this work. The method was based broadly on the atlas developed by FAO, Chechi et al. In 2015, as well as national atlases from Sudan and Mali and Kenya. So we took a lot of lessons from them. We reviewed pre-existing data sets at the national level for the period of 1990 to 2024, and the results of targeted field investigations from 2015 to 2022. The TTCU stands for the TETA and Trypanosomiasis Control Unit was the main source of our data, but we also got additional information from the epidemiology unit that was mainly on AAT data. This information is what they collect monthly. We call them the veterinary monthly return forms to the EPI unit. So full data sets from 1990 to 2022 and AAT occurrence were all collated, they were harmonized, georeferenced, and centralized in a database. The data was structured in 3 sources. One for entomological data, that's the TETA data. one for the sources where they were coming from, and the other one for AAT information or epidemiological data. The data trackings, like I mentioned earlier, we use bionical tracks. We verify the coordinates and the survey size using GeoNet, Gazetteer. We also use Google Map, we use Google Earth, and then we use the Ghana Digital Postal Address System. And in some cases, we have to call directly to full staff to give us some information. We use a free open source GIS, Quantum GIS. And then we use the progressive control pathway framework by Dr. Diallo et al. To assess the past, ongoing, and planned control activities. All these different information layers were combined to attempt to map the progressive control pathway status of the different regions in Ghana. So, in your screen, you will see a map of Tete presence and then the presence of AAT. It will interest you to know that we were able to find coordinates, geographical coordinates for all identified locations that were used in the web. Historical data and variety of reports, data generated by Tete Control Unit, and those we got from the EPI unit, plus 12 published articles and unpublished data, 3 articles published in conferences and proceedings were all included in this work. The data components of this work included 2,830 tracking events. We caught a total of 19,382 flies. And 3 important species of flies were detected, as shown here in the figure. Mosquitoes, we had tachinoides, and we had papalis. It will interest you to know that tachinoides was the highest percentage, 67%, and that was the most abundant fly and widely spread in the northern parts of the country. We also had G. papalis and G. morsitans, 30% and 7.6% as shown. For the AAT component, the database included 491 records. A total of 15,452 animals were tested, mostly cattle, small ruminants in a lesser amount in a few pigs and a few dogs. These results from dogs are mainly from the western region of Ghana, where dogs that report to the clinic most of the time come down with tricks. T. virus is shown to be both more prevalent and widespread compared to T. bullseye and Congolese. And here in the figure, we show you the T. Congolese map, the presence and the absence. We also show that of T. bullseye and T. virus. Now, this what we are demonstrating at the moment here, that talks about the comparative Tete fly densities in Upper West, was an attempt to show you that there is a continuous effort to suppress Tete densities, even with the little funding that we get. So you will see here in the table that from 2011, 2012, up to 2021, there's a conscious effort to deploy targets, to do community awareness, to do ground spraying, and to use insecticide-treated cattle when resources allow. That is what we see here in the graph showing the reduction in the fly densities. Yes, here there's a peak here in Konchoku. That was a long break in the intervention that we didn't have resources to do anything. So you can see from 2011 to 2015 there was a break. But again, we picked up and we started doing some intervention that has shown there in the reduction of the fly densities. Here is for the Upper East region. There too, we are doing continuous intervention. We are doing a lot of community awareness creation, because sometimes when the targets are deployed, farmers tend to take them and move them to different places. So we continue doing awareness creation, we continue deploying targets, and we are conscious of one particular spot, Cairo, in the Upper East region, where fly numbers are high because of the dense vegetation there. So we do a lot of ground spraying there and target deployment. Based on all the activities that we've been carrying on, the epidemiological situation and control activities, we try to do a self-assessment of the national capacity for AAT control. And then with that, and by the guide from the Dr. Dial's progressive control pathway, we could consider that the Upper West region of Ghana is at a later stage 2, because that is where we did the attack intervention, and that is where we are also continuously putting in interventions. And then we consider the Upper East region and the parts of the Northern region as early stage 2, and the rest of the country as stage 1. The rest of the country as stage 1 because in the earlier map shown, we know roughly the situation there, though we are not doing any active intervention in those parts of the country at the moment. So reviewing all the data collected over the period of 32 years has enabled us to have a meaningful epidemiological picture of Tete and AAT in Ghana. Despite the fact that there's an amount of data, the amount of data is relatively limited, we can confirm that AAT is widespread across the country, especially T. virus. We can also say that only 3 species out of the 10 that were previously mentioned by Mahama were found during this period we worked with. Glossina papalis gambiensis was found to coexist with Tachynoides, and then Glossina papalis occurs in smaller numbers from the work we did. We also realized that in northern Ghana, Glossina morsitans was found only in the game parks and around the Nasinga Game Reserve. Despite the fact that the data is relatively limited, AAT is widespread, like I said earlier, in the country. The practice of testing clinically suspicious animals prevents us from really estimating the prevalence. That is the information we get from the epidemiology detective. Hello?
Yeah, we can hear you.
Which is limited in Ghana, when used, may be able to determine relatively higher cases and then could increase the number of positives we see, as was stated by Adam et al. In 2011. Having access to research data from others did not prove easy unless the Tete Control Unit was involved in collecting data from the researchers. They were not too willing to share information. So most of the information we got from publications we had to extract ourselves. The self-assessment of the national capacities for mapping the country's situation in terms of progressive control pathway status is the first concrete application of the national level of principles that were outlined in a previous publication by Dr. Dial. The PCP map also exemplifies how PCP zoning can be based on units of intervention, relatively homogeneous in terms of control and surveillance data and activities, because this information is useful for operationalization, maximum operationalization of the progressive control pathway. It is also important noting that although 2 places could be at the same stage of PCP, it could be at different levels of implementation. That is what we saw in the Upper West and Upper East region of Ghana. They are all at stage 2, but one could be termed an early stage and the stage 2, and the other at a later stage 2. The example of Ghana illustrates the need for a final prioritization of the different stages of the PCP. The Atlas of Tete and AAT in Ghana is a flexible and dynamic tool that enables us to update the entomological and epidemiological situation, thereby assisting decision-making in the control of trypanosomosis. Harmonized georeference information at national level could also be used for mapping and doing advanced analysis, like prediction maps that were done by Mahama et al. And by Gideon Chechi, as well as for targeting new data collection exercises to fill the geographical gaps that have to give us a more complete picture. Although the information we had was limited, it was sufficient to assist the mapping of the different stages in the country. More information is needed in space and time for evidence-based decision making. This is particularly true for AAT, for which data are relatively and mostly based on diagnostic methods characterized by a low or very low sensitivity. PCP map of Ghana also exemplifies the PCP I've done that already, and it developed. Because of all this that has previously been said, it is useful and for one to develop the roadmap for the country for the next 5 years, if resources allow it, because then we can see what is going on, what has been done, and what could be done to improve the threat control activities of the country. Both the country self-assessment and the national level PCT mapping for Ghana could be looked at by other countries as a template for other countries to follow. I would like to express my gratitude to the staff of the 10th Leishmaniasis Control Unit and other staff of the veterinary services of Ghana for their help during our field missions and for sharing surveillance data with us. I would also like to acknowledge the assistance of FAO for this study, which was supported by the government of Italy through the project of improving food security in sub-Saharan Africa. Last but not the least, I am really indebted to my supervisors who took time to check every minute detail, even verification of coordinates. Thank you.
Okay, thank you very much. We will come back with questions later, but now we move on to Margarita, who will speak on the Atlas of Sura in Spain, and that's also virtual, online. Margarita, are you ready?
No, it's me.
Yes, we can see you.
Okay. May I share? Did you see my presentation?
Yes, we can see as well as presentation.
Excuse me, do you see my presentation?
Yes, we can see your presentation. We can hear you.
Yes.
Please go ahead. You can go ahead. We can hear you.
I cannot see you.
We can hear you. We can hear you. Go ahead.
Go ahead. Okay. I go ahead. First of all, I would like to thank you for the invitation, for let us to present our result related to the first steps in the development of an atlas of the Sura in Spain. We would like also to thank all the people who have been working with us, with a special mention to our colleague Giuliano, who is present in the room. Just a brief scope of what we are talking about now, in order to the people who are not particularly focused on this disease and in the Canary Islands particularly. This is the main index, just very few words. It's the Combat project. We're going to present you, for those of you who don't know them, this project. Second is just the trypanosomes that are pathogenic here in the Canary Islands. Then we're going to speak about the Trypanosoma evansi in Spain, and the fourth is how we have developed this atlas. So we're going to present you just a few results, just a preliminary, because this is working on it in a publication that we will present in the next months. So we are going to finish with the next steps in this work that we have been working on it for the last months. Remember that we are related to the COMBAT project. The COMBAT project is controlling and progressively minimizing the burden of animal trypanosomosis, who has the objective of need of control of the disease. So we want to increase the knowledge to control the tools that can be implemented, calculate the dissemination risk and the communication. We are 21 different organizations participating in this, and a coordinator by ISCTRC. Also, we would like to highlight that the University of Las Palmas de Gran Canaria, where I'm now presenting you, we have several tasks related to the epidemiology and the control of the disease here in the Canary Islands, Spain. Remember that these trypanosomes is a protozoa flagellate that is primarily hematic and mainly transmitted by hematophagous diptera, and they perform the part of their life in the vectors of part of the host. So the important species are those who you can see in the presentation, but remember in the Canary Islands we have only found one species, is Trypanosoma evansi, who originally have been imported from Africa. It's very important to have into account that these trypanosomes have a mechanical transmission. So for us, it's very important to understand this situation, because does it multiply in the insect vector, like Stomoxys or Cabanos or whatever. We don't know what is in the Canary Islands, how many or which insect vectors are here. So we have to study this. And also the dromedary camel, who is a species who we have in the Canary Islands for centuries, and is the one of the most susceptible hosts that Dickens have published in 2013, and produces the surra. That's the main introduction. Sorry, very quick. So Trypanosoma evansi, we have identified this disease in Spain in the first case, first clinical case in 1997 in Gran Canaria, in the Canary Islands. We have done multiple epidemiological studies in our university, most of them to assess the prevalence in our islands. Remember that this disease was imported with the dromedaries, came from the north of Africa, the African continent, to our Canary Islands. These studies has been done related to the seroprevalence in some islands. For example, in 2000, 444 samples were studied, and with a prevalence related around between 7.5 in Tenerife Island and 10% in the camels in Gran Canaria Islands. So we, after these studies related to the prevalence, we need to implement the control measures and treatment of these animals. After several activities that we have been done for many years, recurrent cases in a specific area in the island of Gran Canaria continually appear. So we have to continue with the trypanocidal treatment. We elaborate some hypotheses to explain this fact. For example, we have developed one cross-sectional study and one entomological study, among others, that have been published by Rodriguez et al., one of our college, who was his PhD in those years. So the steps was to establish a monitoring and control system. That was done not only with our university, was done with the Department of Agriculture, Livestock and Fishery of the Government of the Canary Islands since 2017. We have, after the identification of the positive animals using the CAT-TMSI, and then those who were positive, PCR was completed then in order to better diagnosis. So the outbreaks of the disease all were derived from the dromedaries that were exported from the Canary Islands. So all those animals who came to the Canary Islands were transported to mainland Europe. One was described in 2008, by the Cairns, was in the Department of Aragon in France, with some dromedaries exported from the Canary Islands in a sheep farm that was affected there. And then also in mainland Spain, in Alicante, some exported dromedaries from our island to a mixed farm. There was some horses that was infected by Surra. So we have to study as a whole, as our colleague Veronica had explained us just in several minutes ago, related to develop an atlas in order to facilitate all the information, and that's why we learned two objectives. The first was we need to obtain a comprehensive picture of the Surra in whole Spain, and also to facilitate the surveillance and the cultural activities. For those, we have used a method employed by the AIO for the Continental Atlas of the transmitted African animal trypanosomosis that Jackie have published in 2014, with data sources from 1997 to 2022. With this information regarding to scientific publications, PhD theses, all documents for monitoring the disease, different conference proceeding and sampling documents, we create a database and a data repository. With these data sources, we achieve a digital repository. Basically, it's an Excel file where every document is there. And then we have information related to the animal samples and all the Surra cases, with all the data of the animals, read the number, sample of the year, the diagnostic, the method that they have been using. Second sheet is a location and georeference sheet. I will later explain something problematic with this point. And then a sort of information with all the publications that we have been done for many years, for all these years. So related to the location and georeference, remember that it was used with a special software dedicated from the Canary Island government to identify exactly where the farm is. Remember that the Canary Islands are very small islands, so it's not similar to those big countries in the whole Africa, so it's very easy to identify the farms as individuals. So we have a problem with the privacy with these farms because they are related to the law in Spain to preserve the anonymous of these farms. So we have some trouble with this when we built the map, always took the map. But we used it, there were results from 1997 to 2022, was an estimation of these sampled animals in different species for these years, also an estimation of all the positive animals using the different diagnostic techniques. Some information is here in this table that you have on your left hand, but with all the latest sampling data from 2022, that we have been working with the Department of Agriculture, Livestock and Fishery of the Government of the Canary Islands. The good news is there are only 4 serological positive animals for Trypanosoma and no positive PCR has been detected for the last years. So we are on the way to control the disease in our territory. The next step is further development and refinement of this atlas, that's with the support of the AEO. So we want to create new maps and new updated studies. Also, we have to add a new sampling that we are completing with the combat triad, and also refinement of the manuscript and data processing. Also, we want to develop a new study, particularly in the epidemiology of the disease, investigate all the involvement of the hematophagous diphterans in the Canary Islands. I remember I told you that there was not too much information about which vectors are located in our territory. So we want to show exactly what is the current status of the disease in order to the future to control this disease. Currently, we are under development of this project. And thank you very much for your attention.
Thank you very much, Juan, for that presentation. We will now move on to another online presentation from Bedaso Kebede. Bedaso, can you hear us? Can you hear us, Bedaso? Silas Ledzele from Cameroon. Juan, can you remove can you unshare? Can you stop sharing? Okay, thank you. Bedaso, can you share your slides?
Sorry, may I present it tomorrow? No, on road to go home.
Bedaso, we are waiting for you to share your.
Yeah, because I'm out of town. May I present tomorrow? Sorry. Excuse me.
No, we are running behind schedule. We're running behind schedule, so we'd like you to present now. Are you ready to present? As we wait, I'd like Marine Getahun to get ready. Bedaso, can you share your screen? Okay, please. Okay, Merit, come and present. 10 minutes.
Yeah, good afternoon, everybody. My name is Merit. So we have heard a lot about transmitted trypanosomiasis. Mine will be the non-transmitted trypanosomiasis while the open my presentation. So to save time, we, as you have seen that you can find trips everywhere outside the SESA belt. The question we are asking is how trips manage to sustain the circulation both in the insect and livestock, the outside the SESA belt. So you can see here such a very restricted distribution, but trips is everywhere. So that the question is, what are the adaptation mechanisms by trips, to circulate in those places in the absence of its biological vector? So you can hypothesize so many things: mechanical vector, continuous introduction, all the others. We'll try to give you some evidence for some of them. So as you can see here, if you sample livestock, especially now here camels, you can see that there are different types of trypanosomes infection with a different epidemiology. You can see that this camel was infected with trypanosome evansi, and the other one with vivax, and this one mixed infection with evansi and anaplasma. You see, this is a very strong bull, but was very sick. You see that one. So even you can see the PZV is low between the infected and the other one. You see this is the place where we have this. The orange one shows the SESA distribution map. It's an old map, of course, SESA in Kenya, but we sample in a place where there is no SESA flies. But you can see there are trips in those animals that you can see that here. We want to know how those trips are circulating. So you can also see that, as I said, one of the reason could be mechanical transmission. So you can see there are various flies are there in those places which are, you can also detect quite complex trypanosome in these flies, as you can see here. We also compared the trypanosome dynamics with Glossina pallidipes we collected from the Shimba Hill area where SESA is. As you can see that we can find a very comparative trypanosome prevalence between these vectors and the biological vector. So you can also see here there is a quite a correlation between the trypanosome between flies and the camel here. So it's not only in camel, but even the other livestock, you can see that quite complex pathogens are found, like in cattle, goat, sheep, and all these are cohort with camel. You can see that. But one interesting thing is here, in this livestock, the trips was asymptomatic. You can't detect using the microscopy, only with the PCR. So as you can see here, we got quite complex and many of the trypanosome, but we also had a problem to differentiate trypanosome into brucei and then evansi. As you can see, all of them, we put them as trypanosome, but then we invited Naomi as a master student, and then she used the microsatellites. Then she was able to dissect the two trypanosome into two clusters, as you can see it here. The most red one is from the northern Kenya, and this one is from the coastal Kenya. So you can see that there is an independent evolution in trips between these two places. We can also see that, interestingly, we found trypanosome vivax was clustered into three based on our microsatellite analysis. But we also found the three cluster of T. congolensi. The interesting thing, we found the independent evolution between vivax and evansi, or trypanosome, but the T. congolensi were the same between the coastal Kenya and the northern Kenya. That means there may be continuous introduction of this parasite into those places. So the other question could be, there is a vertical transmission of trypanosomes. We found that abortion is very serious in all these livestock in those places. As you can see that there is high rate of abortion. And then from these livestock, we picked camel. We picked about 67 camels with a recent history of abortion from day 1 to day 15. As you can see that the abortion is common along all of the age, from year 4 up to year 25, all the camel have serious abortions, and about 38% of the pregnancy was affected due to abortion. So we really want to know what are the factors that are causing this abortion. So when you see these camels with the history of abortion and the healthy ones, There is no difference in their packed cell volume. They look very healthy, all of them. But we found that from those 67, only 3 camel had got trypanosome or Evansi positive with microscopy, but with the PCR, 25% of them, 25 of them or 37% were trypanosome Evansi positive. That might be there. And then the other thing is you can see that here, with the repeated abortion, there is a positive correlation between repeated abortion and trypanosome Evansi infection. So trypanosome Evansi infection might be the main reason for this abortion. So we need to find the reason for this vertical transmission. As you can see, this camel, she is 8 years old. She had a very interesting story. She aborted 3 times, but at the 4th she managed to give birth. As you can see, this calf was 7 days old. But when we the screen, you see the calf and the mother was positive with trypanosomes, but the calf was having so much parasite in the blood. You can also see it in the PCR here. This is the mother. And then also we found 100% match in the DNA sequence. So that means we say that this calf got the trypanosome from his mother because he's only 7 days old. If you want to know, like to get that much parasite, you need to wait until 15 days to get that much load. So this is another way it shows that they are the same. So the thing is, we need to make vector control, and so that we need to understand how this vector interact with their host. We need to make a good trap that's selective, attractive, and also good carrier materials. We have formulated some attractant with the nanobit formulations. The other important thing is also we can also do repellent. So we put our repellent inside the existing camel collar. As you can see, we're able to reduce the feeding of flies on this vector carrying the repellent. So the other important thing is we need to, we can't repel or attract each and every fly. We need to treat also livestock. But one of the problem is diagnostic. So what we have done is we have infected, artificially livestock with trypanosome. You can see that this is a parasite load, and the red one is a PCV. Over the air, the PCV is decreasing. We approach this diagnostic from chemical ecology perspective. That means we want to see how the odor change when a camel or a cow is infected. So we have collected odor from the urine at day 7. So we found there is significant change in the odor profile of healthy and infected livestock. As you can see, this is one of the biomarker one, picresol. We have another phenol and or ionone. So we are trying to use, can we use this biomarker for disease diagnostic, so to simplify or democratize this diagnostic, which we are using PCR and the microscopy. So this is the result we found. As you can see, yes, using this biomarker, it's possible to detect whether a cow or a camel is infected or not. You see here, this is before infection, this is when it's sick, and this is even after treated, so that even our diagnostic detects an active infection. So you can even use it for follow-up of your drug is working or not. And the other one is also here is the camel when infected. This is a urine odor profile. When it's healthy, you can also see here, and these 2 camels are sick. And you can see when we compared our diagnostic with microscopy and PCR, our biomarker is even sensitive, the same like the PCR. So yeah, this is how we validate using field sample. You can see that our diagnostic is very sensitive, the same as like a PCR. Even asymptomatic ones that are cannot detect with the microscopy, you can detect with our simple biomarker-based diagnostic. So the other thing, you can also see between the asymptomatic and then the one that are really, you can see by microscopy, you can see the color change between these 2. So that means our diagnostic is very sensitive. So it can work in goats, even when you also some selective, and can be done by the farmers themselves. This is Arankole. He brought his own camel and he did his own diagnostic here. So it's a very simple, user-friendly. So these are my conclusions. Trypanosome is widely distributed in the absence of its scissor vector. Mechanical vector and vertical transmission may sustain trypanosome in the absence of its biological vector. I forgot to mention we have a very nice poster about the mechanical transmission by stomoxis by one of our master students. So vector control and early disease diagnostic followed by treatment is recommended. Development and adoption of simple pastoralist farmers-friendly Nagana diagnostics that detect, including asymptomatic infection. I think the one we have, we need like maybe partners, sponsors who can also take that method into the next level so that it's available for farmers. We need to also prevent vertical transmission. I think, like, as I shown you, that all those camels that aborted, they have trips, but they were asymptomatic. You can't using, they look also healthy, they have a normal PCV, but you know, when you use high sensitive technique, you can see that they have that trips that can kill the calf and induce abortion. And also, efficient management, equal emphasis should be given to non-sessa transmitted trypanosomiasis. So I would like to thank our donors, all ECP donors, and then thank you for your listening.
Thank you very much, Merid. We will move on to have just 2 presentations, and then we'll have a discussion. Ahmed, are you ready? After Ahmed, we'll have Mamathiano Bakum. Where are you? Have you loaded your presentation? If you haven't, please do it now. And let me just take this opportunity to ask that the remaining presentations should be loaded before we leave today, so that we are not delayed tomorrow. So you'll present after Ahmed? You have a presentation there? Ahmed, is yours loaded? So you come after after him then. So please go ahead. Yeah.
Mine already found. Okay. Thank you. Which one are you using for pointer? This one. I think it's not working. I think it's not working. Okay. Good afternoon. My name is Dr. Ahmed Kadle from Somalia, and I'm very glad that today I'm representing my country and always going around in the global world, because Somalia is very isolated geographically and politically. They are not going around since the civil war. So today I am talking about the animal trypanosomiasis and saxifali in Somalia. Somalia is a livestock-dependent country, and its support is about 18 million people in our country, and the livestock contributes to the national GDP 40% and 80% of the export earnings. So you can see how it's important. And the saxifali and discarding this one. And if we see the original of Somali, it comes also linked to the livestock, so and mal, means go and milk it, even the Somali, go and milk it. So we are a livestock dependent country, and this indicates for that. And we have seen some civil war in 1991. Now it is some reconstruction. And the civil war is distracted the education sector, the researches, economic, and everything was distracted. But fortunately now we are reconstructing. Sorry. We are reconstructing, but you know, the geographic isolation and political isolation for our country led the preventable diseases of animals and humans are neglected to us. So our people are still, and animals are still suffering from preventable diseases like TB and even neglected tropical diseases. The saxifali, it is just confined area in the riverine areas, Shabelle River and Juba River, and then with the coastal border with the Kenyan side. And it is about almost in the southern part, 4.8%. It's affected, and this will affect about 17.2 million livestock at risk of septicemia. But previously, before the government collapsed in the civil war, the Somali was rich of data on trypanosomiasis. So suppose if our government did not collapse it, so now we are rich on data and we can already convince and eradicate the thing. So we were doing 1919 up to 1990. The data was very good, but unfortunately the civil war stopped everything. And previously, we have used parasitological and serological. No molecular techniques have been done. In ruminants, it was 4 to 28.6%, and in camels was ranged in 1.7 up to 56%. Previously, the studies was recorded congolans, 5-XCMI, Brucei, and Evansai. But nowadays, we are lucky we are updated some data. I am happy the first one who did a molecular technique in the country and sequencing for 2 papers, and you see it is just recent in 2019. So a country that is dependent on livestock and there is no data to depend on it to control for that. And the occurrence was confirmed in 17 out of 18 regions of the country. This just not trace it because the Somalis are pastoralists, the animals are going around. So it is just every animal in their region was tested, and the positive one is 17 out of 18 regions. The hat is unknown in our country. Also Kenya and Ethiopia were present, but previously we don't have. And also we have tested the reservoir of animals, but we did not find in animals the hat, the Rhodesians one. But recently in 2023 February, we did a prioritization of One Health in zoonotic diseases, and we come up with 7 diseases. Trypanosomiasis was included. So imagine we don't have hat, but it is included in the zoonotic list prioritization from different advisories and different technicians. And this because of socio-economic importance of the disease to our country. And this is linked to the sustainable sets and trypanosomiasis control for socio-economic development for our theme of this conference. And we have done a hat reservoir on animals, but fortunately we did not find. In 1928, 400 working oxen was distributed to the riverine areas to do their bluffing and agricultural development. After 4 months, all were died because of trypanosomiasis. So because of that socio-economic importance, we prioritize it in this year. Previously, there was a Department of Sets and Trypanosomiasis before the collapse, and they did some eradication program. They succeeded but not sustained it. And that is what we are seeing the past 2 days. Just we said, first operations was successful, but reinfestation was happening. Also, an International Committee of the Red Cross, they have done some vector-borne disease, vector control, and also live bait, just to control the septicemia in the areas. I have worked in this project with as a veterinarian. We did, and we reduced it 50% of the septic challenge. But unfortunately, reinfestation was happening. 50% reduce it, but not sustain it. And this is because the people, they use it, the closes of the travis, and for removing on the alcoholics, and even for the blue one, even for school children. So you see it, it's not sustaining. That is what we said, we need a bottom up strategy. Then at Abrar University, we are doing sets and trypanosomiasis, and in 2015 up to 2025, we have published these two, and we are ongoing on Marvin Setsyphilis survey of sets and trypanosomiasis and other Bacteroides and trypanosomiasis in wild animals, with partners in Tanzania, Brazil, Sao Paulo also, and we just started communication with EIT and also with PAT on Atlas. Finally, on future direction, the most important awareness at different levels to sustain and to increase the sustainability of the project. At that picture, when we failed the first time, just we started to communicate with the community to understand what is the problem, and then we started to give them the travis from them, and they invested their own, and then it's continued, but it's not continued as much as possible. So we need a bottom-up control strategy. Also, we need special attention because the government, in the previous, we have a Department of Sex and Trypanosomiasis control, but now we don't have. And even the batik and even the other initiative that is running in the continent is not, Somalia is not part of it. So we need special attention for government, academia.
And international organizations, at least to focus this isolated country. Cross-border control is also important because we have a cross-border with Kenya, and now we have seen a publication of 5 cases from Ethiopia. So we need a cross-border control, and also we have to map this sex and trypanosomiasis so as to be able to control. And resource mobilization is most important. Research and surveillance is to be continued, and then accurate and efficient identification is most important. That's all. Thank you very much.
Thank you very much, Ahmed. Now we shall have the last presentation. After that, we have a brief discussion, and then I'll be requesting Professor Abacha to make a statement about moral living.
Good evening, everyone, and thank you, Andrea, to give me the opportunity to discuss with you also about our knowledge about animal trypanosomiasis in the area, free area in Senegal. And then Governor allowed me to make my presentation in French. So, can I go? Oh, right. Ok. Comme vous le savez, en fait...
No. In Senegal.
Continue.
So the control for flyers has been established in May 2006. This program has the goal, is targeting this program is targeting area where we have also glucina, and we have areas in the west of Senegal. We have the center
du Sénégal. Cependant, on n'a aucune information au niveau du nord du Sénégal où quand même on n'a pas...
We have no information in the north of Senegal where we have no so much idea about this trypanosomiasis. Now, through the Comba project, the people talked about a consortium which is made of about 22 partners from 14 countries. And you can see the posters. Actually, you can go look at the posters. Through this project, we were able to have some questions. We also have questions. What is the situation of the animal trypanosomiasis in the areas where we don't have a glycine in Senegal? What is the diversity of these vectors of this trypanosomiasis? In fact, these are the vectors I'm going to talk about. The vectors are much important in the transmission. And then, to respond to this question, we collected blood. It's true. We call from cows, the small ruminants, and then for the horses also, and donkeys. And then from that, we needed to carry out a microscopic examination to use the conventional PCR, a standard PCR. And then from the serum, we always carry out ELISA testing. Now, regarding the mechanism of the vector in the area where we were able to have some glycine, we are in an three areas were selected in the north, the east of Senegal, and then in the west of Senegal, and another zone in the center of Senegal. In each one of these areas, they were selected where the modern farms, natural from a place from the rivers and some forests where we deployed. And then these were followed for 5 days. And then during the rainy season and during the dry season. Now, depending on what we have as a serological outcomes, we found the high percentage at the center area, at the level of the bovines, as the level as the horses. Contrary to the northeast of the Senegal, where prevalence was very weak. Now, regarding parasitological detection, microscopic examination was detected from the Trypanosoma vivax. Vivax only found in the cattle in the site which is found in the north and eastern part of Senegal and also the center of Senegal. But this vivax was only for the cattle, not for the horses or the small ruminants. Regarding entomological surveillance, depending on the seasons, we have some apparent densities which vary from 0 to 14, and varies from 0 to 14, depending on the localities. And then 0 to 7 during dry season. Now, depending on these areas and the locality and apparent density has really varied considerably. Now, you have to note also that in total, we have about 12 species where we had some which have been represented at the level of the center of the region, and where we have which is free from the glycine. Now, well, you have to realize that in parasitological detection, some of the 3 VVAX was also detected at the level of Stomos castus. And then also, what can we conclude from our study at the level of the areas which are free from, we have seen a strong circulation of a VVAX in these areas with a very strong seroprevalence in certain sites. In fact, more than 12 species of mechanic vectors which belong to Tabanics and the Stomoxys were found, and the Stomoxys castrans were also found. What do you want to do in future? We have some study which needs to try to see with meta barcoding, which is planned within the combat project, and some tests of some certain markers which are able to help the range of these mechanical vectors. And then also if this mechanical can develop some resistance or not. And then also they are also being validated, try to see so that you can carry out this study. Another point that we want to do is to include this area in the national program of the fighting, so that we can reduce the density of the mechanic vector in this area, which is free from glucine. Well, I cannot finish without thanking our partners, European Union, for the financing through the combat project. And thank you very much for your kind attention.
Okay, much for that presentation. The presentations that we've had are now open for discussion. If you have a question, please raise your hand. 1. Is there another question? Okay, please go ahead and specify who the question is for.
Thank you very much. The question is for anybody who is talking about the presence of trypanosomes in CHC-free areas. What I'd like to know is, you provide very clear evidence that these trips are being seen in tabanids and stomoxys and things like that. Are you seeing any, and particularly serious, illness in cattle in those areas? In other words, although you're seeing them in the insects, are they transmitting it to cattle? Are you seeing cattle that are sick with Nagana in those areas? Thanks.
Okay. Makun, you want to? Sorry, Makun. I think Merid, you can respond to that, although you've seen more camels than cattle.
Yeah, thank you, John, for the question. Yes, we have seen we detected trips in the other than camel, like cattle, goat, sheep, but as I said, the infection was asymptomatic, so you don't see them in with the microscopy. You have to use like PCR to see trips are there or not. So that's my answer for your question. Yeah, of course, what we sampled, as I said, they were asymptomatic. But, if you sample more, I can't say that they were not sick, because the cattle we sampled, they were asymptomatic. We just want to know, but they were not sick. Yeah.
That doesn't mean they were not suffering some loss, of course. Johnson, you have a question or you want to respond?
No, I just wanted to make a comment.
Okay.
Yeah, so my comment is some years ago, I remember that the African Union, NEPAD agency, came up with a program for laboratories like ours and others to train and build capacity for countries that had gone through conflict and they were just emerging out of conflict, because those countries did not have capacity for SESE work and trypanosomiasis. And I remember that we trained quite a number of young people. Those people are now scientists in their own rights in their countries. Just making this comment with regards to what our colleague from Somalia presented, that perhaps something that the African Union could consider, how to help countries that are reconstructing like their country to build capacity. Thank you.
Thank you very much for your comment. John, did you want to hear about the T-Vivax infections as well, mechanically transmitted from Senegal? Or you are satisfied with the T. Evans I work? Okay. Well, to your question, it was a gentleman from Senegal. So I think you found some T-Vivax in cattle. Were those cattle clinically sick?
Oui, en fait, pour répondre à cette question, on n'a pas
To respond, we didn't find cattle which were sick. If I would try to explain, on the ground, in fact, we tried to get some Vivax trypanosomiasis at the level of the cattle, but we did not find sick cattle. Thank you.
All right. I don't know if you are suggesting that mechanically transmitted are less virulent, or what's the implication?
No, I mean, I just think this is a very fascinating thing that's happening. Now, in view particularly of the fact, such as the great rinderpest episodic that swept through Africa in 1896, removed tsetse flies, for instance, from the northeast of South Africa, the whole of the Kruger National Park. So there have been no tsetse flies there for 140 years, but there's no trypanosomiasis problem. So you might have expected that there would be. Going shortest time scale, of course, it's now 20-odd years, I think, since the tsetse were removed from Botswana. There's no suggestion of any trypanosomiasis in cattle there. So it could be, of course, that things are just very different in southern Africa than they are in the Horn of Africa and elsewhere in Africa. I mean, I find this fascinating. Of course, if it's true that, in fact, we can get that mechanical transmission is sufficient to maintain the presence of trypanosomiasis ad infinitum and also for the disease, then we're in a lot of trouble, aren't we? I mean, looking on the bright side, it means that we might have a job for a few more years.
Okay, thank you. All right, do you have any more? Yes, there's one over there. Ahmed, did you want to make a comment or you are satisfied? Go ahead.
Okay. I had a question concerning those ones who presented in the areas which are free from SESE, but they found Vivax. Do you have any idea of the virulence between Vivax transmitted by the glycine and the Vivax transferred by the mechanical vector? Does someone have an idea? Not necessarily the ones who are presented, but the ones who have the experience. Do you have any experience of the difference between the virulence between the two types of Vivax transmitted either mechanically or through other way? Thank you.
Does anyone want to respond to that? Who has experience with areas, maybe in America, where there's transmission of Vivax without SESE? But I think the question is really complex because you're also talking about genotypes, which are different in different areas. For example, in coastal Kenya, you have very virulent T-Vivax. similar to what has been found in parts of Mozambique. But we know that I think somebody was presenting on T-Vivax using primers called TVW. That's quite a mild infection as far as I know. So with Vivax, you're talking about different genotypes in different areas. So I think there's no straight answer to that question. But it also refers to what I was asking John over there about whether the suggestion is that mechanical transmission results in a more mild disease. I don't think anyone really knows that. Does anyone know that? Sam, you have a question or an answer?
Just a comment. Okay, merci.
Thank you, Dan, for the floor. I think it has been clear. He wanted to know if Vivax transmitted by mechanical vectors, are they making animals sick? You gave the response, and naturally, you can have parasite, which is quite virulent depending on the space. But Vivax can become virulent and make the animal sick. This kind of the problem, in a general way, that's what affects the situation of the mechanical translation. We know very well that other trypanosomiasis can also be transmitted mechanically, either through stomachs or etc. So it's a real problem. This makes animals sick, depending with time. When the trypanosomiasis is a period where the animals are quite well, it's automatic. But there's another one, another component, where the animal, in a clinical way, can find some elements of the disease. I think that's also much important. It's for this reason that the presenter said the areas infested by the mechanical vectors need to be subjected to control. These are some of the reasons. If they're not transmitting the disease, we do not be able to involve in the control of this in this locality. Thank you very much.
Okay, thank you, Sam. Merid?
Yeah, thank you very much. I think we have a good evidence, for example, in Sudan, where they have found the T-Vivax, for example, in camel, how deadly it is. We can say that even in our experiment, when you use the mechanical transmission, we can see mice died from mechanical transmission, that they just fly fed only less than a minute, and then you can see that the mice die. So I think mechanical transmission, okay, as Dan and the other mentioned, it depends on the virulence of the strains and even the host that the animal, how good it is in that one. So we can't undermine those kind of transmission in the sustaining and then the economic impact in the continent. Thank you.
Okay. Thank you very much, Merid. One last question, comment?
Just a comment.
Just a comment concerning the mechanical transmission. For me, you can understand this is an issue of space. What I've found is we can have some kind of a transition in terms of the ecology of the vector, biological ecology of the vector. For me, the transmission by the biological vector and the transmission by the mechanical vector, it is a question of the vehicle of distribution. Either is it virulent species? For me, it has nothing to do with the nature. For me, so therefore, for me, it depends with the species. Sorry, it depends on the species for me. Thank you very much.
Okay, I think we will. Okay, one more. John Kabayo.
No, it's just my take on this very interesting topic, because I'm aware that trypanosomes actually are modified by their environment. And I suspect that if they are in stomoxis or other than the fly, they'll be different. Maybe they'll be not as infective. That's what the closest I know. I am sure that trypanosomes are able to modify themselves. Rather, the modifications happen according to the environment they have. And it should not be surprising that that those in Semoxis might not be as effective as those from Decifrage. I think that's the best, but it's a very interesting research topic, I must say.
I think we'll leave it there. That comment is well taken. Can I request Professor Obacha to come and speak?
So thank you, moderator, thank you, chair, for giving me this chance to communicate a message to our colleagues. Good evening, thank you for the patience. Quick announcement, tomorrow there will be a cocktail courtesy of the Foundation of Innovative New Diagnostics, FIND, and the cocktail will take place at Marina Seaside Restaurant, Seaside, and that's why we are proposing that it will take place at 5:30 so that you have an opportunity to see the beauty of the click. For those who will be attending, we will not have enough time to take you back to the hotel and back and to the restaurant. So we'll be proposing that you be prepared. Immediately the sessions are over, we'll move straight to the Marina Seaside Restaurant. Of course, for those ones who will not be accompanying us to the restaurant, we will have provisions of how you'll be taken to your hotel. But we hope every one of us will be able to join us at Marina Seaside Restaurant, which is about 5 kilometers from here, from Pride in Paradise, about 5 kilometers. And we expect to be there by 5:30 so that you see the beauty of the click and the sea. That means then, as will be directed by the chair, we'll then have to start our day early so that we are able to get to Marina at 5:30. Thank you. Thank you, Chair, and thank you, Moderator.
Thank you very much. Please take note, which means that we need to start on time. And I would just like to reiterate that those who are presenting in the morning, please load your slides before we leave. So immediately this session is over, please load your slides. I will now just say thank you to Draman Kaba, the rapporteur, as I hand over to the chairman, and also just ask that you give a clap to the presenters of this afternoon. Thank you.
Please give another round of applause to the moderator and the rapporteur. You'll agree with me that today we have made a lot of progress. We have had incredible presentations, very stimulating discussions, and for your information, we have covered a lot of ground. In the morning, I was a bit stressed because of the number of presentations that we had to go through. I am happy that tomorrow we shall only be behind by 1 or 2 presentations. So we are catching up quite well. I hope all of us have learned something today. I have a new understanding of the name Somalia and where it comes from. So I've learned something new. But in terms of announcements, I want to remind the delegates from various regions that you are required to nominate by consensus the person who will represent your region in the executive committee of the ISCTRC. We now have nominees from West Africa, and we have a nominee from Eastern Africa. We are waiting for 2 nominees from Central Africa, 1 nominee from Southern Africa, and 2 nominees from Northern Africa. We hope that we can finalize this process by the end of the day tomorrow. Having said that, as the moderator has said, in order for us to make time to be able to go for the cocktail tomorrow afternoon. We need to come early, just as we did today. We start off at 8:30 in the morning. Again, to remind the rapporteurs, please look through your notes so that if you identify areas where we can draw recommendations, then it will make our work easier as we come to Friday. So that is all for today. Thank you very much for your understanding and your patience. We look forward again to fruitful discussions tomorrow. Bye-bye.